Greetings, my name is Konstantinos Christidis and I will be discussing the EvoRoads project satellite-based component. The objective of the EvoRoads project satellite-based component is to use synthetic aperture data interferometry to detect ground movements over time by running a time series analysis over a set of interferograms. Given that man-made structures such as road bridges and pavements are effective scatterers of radar signals, it is possible to track their movement with a high level of accuracy and reliability after collecting interferograms over a long period of time. This period of time is in the order of years. This can be an indication of pavement deformation such as subsidence or rutting, which are in turn an indication of pavement failure or maybe causes of road safety issues, and as such are of great interest in transport asset mass announcement. Now, in order to collect the data, we're using the Copernicus browser provided by ESA. It's very easy to register with this service. And it's also easy to specify a polygon for your area of interest, as well as a time period for which you wish to collect observations for the data preprocessing we're going to discuss next. Now, as you can see, once you have selected the area of interest and the time period for the observations, the browser is highlighting different products that you can download, and as you can see, these cover fairly large areas of the map, and as such they also require a lot of storage on your hard drive. So you'll need to be sure about the number of observations you want to collect, not overdo it, but not have observations that are too sparse over time in order to draw any usable conclusions. This will take some experimentation on your part. Now, thankfully, the Copernicus browser allows batch downloading once you have identified the observations that you want to collect. And these observations can be opened with the European Space Agency's SNAP software. You need to go to the folder of each observation and open its manifest.safe data. Once you do that, you can see on the top left you get a browser where you can access the different components of the observation, and on the bottom left of your screen you see the area of the observation highlighted on the globe. This is to check that you're opening the correct observation and not something irrelevant to your current work. Now, if you open the metadata part of the observation, you can see that you're given the coordinates of its limits. You're given data such as its resolution, so it's very helpful. And you can also open different bands of the observation just to check that it's not empty. Now, once you have a series of observations for the same area, you need to co-register them. This is done in order to be able to actually generate the interferograms that are used in the time series analysis. And once you've done the co-registration, you get a new product generated in your working folder, which has its own metadata and its own data bands, and you can start opening different parts of it in order to check that the co-registration has taken place in the correct manner, that it didn't generate an empty data set, and so on. Now, you can see on your screen the steps that one needs to click through in the SNAP software in order to start generating interferograms. And once this is done, again, a new product is created, which contains not just the interferogram itself, but also elevation data and orthorectified images, which can be used again to check that the interferogram is useful or well suited for the purpose we're going to use it. This concludes part 1, which has to do with data collection and preprocessing. In the following parts of this videos, we will discuss how this data is used to identify pavement defects. Thank you for your attention, and if you have any questions, please feel free to contact us.